So today we are going to cover, this is the agenda, and we're going to start with the basics of why we need policy, what is a policy, and what challenge is policy solving for us. Then we're going to further dive into Kyverno, the kind of policies Kyverno offer, and we'll also have a lab and a hands-on session in terms of writing the policies, and then Sagar will dive deeper into some demos and other use cases which are a little more complex, and we'll then go to the QA session at the end. So let's dive into the policies part. Now, before I talk about why we need policies, I'll take a step back and let's understand what is Kubernetes and what is the challenge in Kubernetes today. So we do know that Kubernetes is complex and it's very dynamic in nature. What do you mean by complex and dynamic in nature is we are seeing more and more that Kubernetes is becoming a way to other teams to collaborate. That means security team touches your cluster, platform team is responsible for the cluster, and developers have access to the cluster. So all the applications are kind of getting, all the other teams are contributing for these applications. When you look at a deployment YAML, for a developer, just the image and the environmental variables would matter. If it's working, then it's good. For operation team, probably if the labels are good, if the selectors are good, and if the pod is scheduled in the right node, that's what matters to them. And for the security team, probably the security context, if the pod is not running as a non-root users, all of these sections matters. So different teams have different priorities and responsibilities. And that's where we understand and we fall into a category where there are a lot of misconfigurations in a Kubernetes cluster, and nobody kind of owns it, because developers are not responsible to own the security part, or the security people are not responsible to own what the developer image should look like or where it should come from, right? So that's where misconfigurations are rising in this particular section. And this is a report from CNCF, which was published, I think, last year, which recorded that all the security threats, and these are some of the posters and headlines that I've attached in here, is you would see all these threats that are happening. The major one reason for this is misconfigurations. What does misconfiguration mean? Misconfigurations can be as simple as you don't have a label to as complicated as the pod is running as a root. Now, I'm pretty sure that you would have seen this or you would have heard this here and there in various demos and presentation, but we still don't understand the impact, right? We know that misconfigurations are the threat, and if any hacker gets the misconfiguration, that can be a vector for your attacks or to just to exploit that particular cluster. But we're still kind of trying to figure out what would be the impact look like. So this is a quick video that you would see where I'm deploying a pod, and here, if I pause it a little bit, it's a bad pod. That means it has all the bad configurations of the world, and if your developers have access to the namespace, they can deploy a bad pod in here. And then what I'm going to do is I'm going to check if the pod is running. So I've created the pod. The pod got created. Now I'm checking if the pod is running. The pod is running. And then what I'm doing is I'm just using a basic command, which is exec into the pod, and I'm going and I'm doing a bash in the pod. And you could see that the moment you go in the pod and you do an exec in the pod, you can get access to your entire host. So here, if you look at the IP, I am in my host, and I can access the Kubernetes certs, I can access the etc folder, the logs folder. I also have the power to bring the cluster down. And how? Just by deploying a single pod. So that is what we are talking about when we talk about misconfigurations, when we say that even a single pod can bring your cluster down. Now, that's one part of it. The other part of it is that now we know that we already saw that misconfigurations can be a vector for your security, for the hackers and other things. But other thing that we have also seen is, and with all this buzz and all the new things about platform engineer, we are seeing platform engineer is more and more about self-service. So what we want to do and what is the goal of platform engineer is we want to make developers self-service. We want to have access, we want developers to have access to their namespace, able to do their job in a self-service manner where they don't have to create a case or come to an operation guy and they'll do the stuff and all this avoiding friction and back and forth. But how do you do that? if you don't have policies today, how do you make an environment self-service and do not have any control? In fact, when I think about it, I feel it's a very conflicting logic for a sense. If I'm asked to own a particular cluster and that entire cluster's configurations and everything is my responsibility, and I'm asked to give developers a self-service model, will I not lose that control? Doesn't that sound like a conflict where I don't know what the developer would be doing, but I'm still responsible to own what he's doing, and I don't know what he's doing, So it's kind of a conflict in the intent itself, and you cannot actually able to achieve the self-service model if you don't have proper guardrails and policies. If I do have policies, what I can do is I can deploy 5 to 10 policies in terms of what I want the developer to do and what I do not want the developer to do. I can deploy these policies, and then I have the control. I have the peace of mind, and I know that my cluster will not get impacted, and I am implementing self-service in the right way. Or else, I cannot find a way to make the cluster entirely self-service. It just sounds impossible to me. So that's where the entire agenda of why policies are needed comes from. Now, this is a picture I have where I'm saying policies prevent misconfigurations, and we want to prevent misconfigurations before rather than in the cluster. If the bad pod is running in your cluster and it's already in the cluster, it's there. So the misconfiguration is already there, and the application is live, the end users are using it, and now it becomes a much more deal to just fix that. Rather, we fix that misconfigurations previously in the pipeline or before it goes to production. And when we think about policies, if we think about what is a policy, because we have been talking about why we need policies, but if we understand what exactly is a policy, so I would say policy is kind of a contract, and let's not even go into Kubernetes. If you just see around in our day-to-day life, we have so many policies. I have a policy at home that you have to leave your shoes out when you're entering, right? That's a policy. Then you have another where just clean up after yourself. That's another policy. My organization has a policy. The government has a policy. Federal rules have a policy. So we do have all these policies, and basically what these policies are doing is it is telling us what you're supposed to do and what you're supposed to not do. It's controlling the behavior of a person. It's controlling how I'm supposed to behave and how I'm not supposed to behave. So apply the same intent in a Kubernetes cluster, where you're deploying the policies and you are kind of controlling the behavior of your users in a cluster. So that's what a policy is. Anything that controls the behavior of the cluster of the user is called a policy. So you might have network policies on your cluster. Those are policies. You might have other set of things. Those all falls under policies. Now, that was all about what is a policy, why we need policy, what are some challenges in the Kubernetes cluster, and what do you see come across when you use the self-service model as a platform engineer. Now, what is a policy as a code? So policy as a code is that you want to apply the same principles that you are applying for software engineering. What does that mean, and why do you want to do it? For example, you have one policy. Cool, you have one cluster. Great. You can write a policy, you have 2 policies, 4 policies, 5 policies. Think about when you have 50 policies. Think about those policies are deployed in production. Don't you require a principle to manage the entire life cycle of those policies? And that is what policy as a code is. Policy as a code is basically using the same principles of a software engineering, where you're testing the policies, you have a proper process to audit these policies, you have a Git repo, or you're centralizing it somewhere, and then you're managing the life cycle. So basically, that's the policy as a code, which consists of applying the same principle, as I said. That can be a version control, that can be the code review, code signing, automated testing. And this is what the life cycle of the policy looks like, where you develop a policy, then you kind of test the policy. You do not want to have a policy without tested in your production. You want to test just like you do it for your code, right? You do not push a code in production before testing it. So all the principles, all the intent that you use for software engineering principles is the same that you do for policy, and that is called policy as a code. So you develop the policy, you test it, you make sure that it has proper version control, it is enforced, you observe that, and then you manage the life cycle of the policy. Policy as a code, when I think about it personally, I feel it's the same way when we were talking about IAC 3 years back. When infrastructure as a code was popular, the reason it was because it was giving a lot of benefits. Infrastructure as a code helps us to have version control. We can audit, we can roll it back, we have everything in a Git. It just makes our life simpler, or else you cannot deploy an entire 50 clusters just manually without an IAC. Think of it the same way, and that's where I think PAC is going along as well. Now, before I talk a little bit about Kyverno, why Kyverno, I want to talk about the space and what I'm actually talking about, right? So this is the same video that we just showed in the second slide, which talked about, just give me 1 second, I'm gonna
take desktop.
Okay.
I didn't have fun.
Okay. Yeah, so this is the same video which I think on the second slide we saw, where I'm deploying a bad pod, and then you're exiting to the bad pod, and then you see that there is you get access to the host, you get access to the entire Kubernetes host and stuff. Now let's look at it how does this change when you have policies deployed? So here it's still the first part where you're going in etcd, you're seeing that it has the access to the host. Great. And I'm showing a little more where again and again you have access to the host, so you have access to the entire folder, you are root in there. And now I'm going to delete the pod. And so this is before policies. Now, I've deployed Kyverno in this cluster already. And what I'm going to do is I'm going to deploy these policies. So I'm just going to deploy, I think, one policy, but we'll see. OK, so I've deployed one policy in here. And I'm seeing the policy is in status true. It's in enforced state. And now I'm going to do the same thing. So I'm kind of controlling the behavior in a way where you apply the same bad pod, and you see that the pod doesn't go by. It's enforced. And the policy is telling you why it doesn't like the pod. It's telling you that your container has all capability drop. And by the way, you can customize that. So you can customize this message. So it's telling you why it is not allowed, what you should go, you should change, and you should come back. So this is the importance of policy. And I would say, one thing is, if you have your workloads in your Kubernetes cluster, and if you're running in production, you should at least have pod security policies. You should at least have the basic restricted pod security policies. That's a must, irrespective of if you're using Kyverno or not. If you want to go with any custom solution, that's cool. But you should have a pod security policies if you're running your workloads in a prod cluster. Now, as I said, Kyverno is an admission controller, and we'll talk more about Kyverno, but as I showed that we deployed a policy in here, but why do you want to choose Kyverno? As you might already know, that you can also create an admission controller, or you can use the inbuilt ones, or you can use other tools out there. First thing is that Kyverno was designed for Kubernetes, but we are also extending it. So it does have the functionality to extend and scan your JSON files. Second is writing a policy in Kyverno is just like writing a deployment YAML. That means when a new tool comes in, there is a learning curve. You need to learn a language, you need to know certain things about it to write a policy. But that's not the case for Kyverno. You can just, if you know Kubernetes, if you know YAML, writing a policy, getting started with Kyverno is very easy. Kyverno not only just validate things, but it can also mutate, generate, clean up resources, and also verify images. So it does have a lot more than just validate. And you can also have two options when you're validating certain resources. Either you can put it in enforce, or either you can do just audit. So if you don't want to be very strict and you don't want to just block things, you can put it in audit mode, and Kyverno creates a report for you, and you can check what's happening in your cluster. So the next, stop the slide showing. Okay. So this is a policy management architecture, and this has nothing to do with Kyverno in general. This is a basic top-level architecture of what does an admission controller do when the request comes through. So if you look at the workflow, you would see a API request. So API request is anything when you interact with your API server using kubectl, using API, using anything, the first thing that comes in your cluster is an API request. After that, there is this HTTP handler, and then there is authentication and authorization. That means who is supposed to access the cluster and what they are supposed to access the cluster. Once that goes through, that's when the admission controller comes into the picture. So if you have any admission controller, and if you're wondering what exactly it does and how exactly it works, and which step does it work, this is where it actually works, where once the authentication and authorization happens, this is where the controller works, and it can mutate your resources or it can validate your resources based on the policies you have. Once these things are validated, that's when your pod gets stored in the etcd, and that's when the scheduler takes it and kind of like schedules that. So it's good to validate these resources before even it is hitting the etcd and getting deployed by your scheduler. So you are blocking or you are checking the pod configurations before it hits the etcd or the database. So that's when the admission controller and the admission review happens in the API lifecycle request. And this is Kyverno's architecture. I'm diving a little deeper into the Kyverno app in terms of what does the architecture of Kyverno looks like. So as you might have seen, this architecture remains the same, but this is where the admission controller sits in, and it has a bunch of other things. So Kyverno do have report controllers, it have background controllers, it do have policies, it has policy exception, and there are a few other things that it can do. What does that mean? Just in a nutshell, is Kyverno can scan your clusters based on the policy, it can create reports for you, and can also scan the background resources and create reports for you. And if there are some policies, because of the nature of the policies, if they require an exception, you can create an exception and you can track that. So Kyverno has an entire workflow of deploying your policies, validating it, providing exception, creating reports. And these are some use cases on the right, which Kyverno can solve. We are going to talk a little more about the use cases later in the workshop. And this is a policy structure, and this would be very much similar in most of the policy. So you would see a policy has a rule, and one policy can have more than one rule. So you can structure a policy with multiple rules, and every rule will have a match or an exclude criteria. What does that mean? Is a rule, using a match and exclude criteria, you can decide where you want to apply the policy for, and it goes as granular as possible. So if you have a use case where you want to match it to a pod sitting in ABC namespace, and the pod has name test, you can go as granular and add those in the match condition. If you have a use case where you're like, I want to apply the policies in my entire cluster, but I want to exclude this certain pod sitting in this namespace with this name, you can use exclude block. So those helps you to just define the scope of the policy. The other section that you'll see is either a mutate, verify, validate, or generate resource. I said either one of it, so you won't see all of them. Remember this, you would see just one. So if you get a policy and if you're trying to figure it out, if it's a validate policy or if it's a mutate one, look at the block and you'll see it will give you a mutate block. That means it's a mutate policy. So a validate policy kind of like validates or checks your configuration. Mutate will mutate the configuration. So an example for that can be if you have a pod with no labels and you want to add a label, app ID can be a good example of a label if you want to add. You can mutate it and add that label, or you can generate resources. For example, if a namespace gets created, create resource quota, create RBACs, and create network policies. That could be a generate policies use case. And then we have verify image, and we also have cleanup policies. That is, you can add a TTL to a namespace or a resource, and the cleanup policy makes sure that post the TTL, it automatically gets cleaned up. So it will help you for your FinOps and cost optimization use cases. Perfect. So these are some of the use cases I've written in here, and I've segregated it based on SecOps, DevOps, and FinOps, but these kind of things interchange. So based on your organization, SecOps might have a different definition, DevOps might have a different definition, But these are all the over things that Kyverno can do. And as I said, you can write different kind of policies. All of that is customizable. You can decide what the scope of the policy is, what the logic of the policy is. So you have a lot of use cases that you can build, and you can use that based on the use cases. Okay, that was all it. Krishna, I would give it to you. And we are going to cover the hands-on exercise. For us to just begin, probably scan the QR code, and you'll have a prerequisite section, which will talk about how do you install Kyverno and what do you do just to get started. And from there, we'll take it forward.
Thank you, Dolis. So general consensus, do you want to take a quick 5-minute break before we jump onto the hands-on session, or are you okay continuing? Raise your hand if you want a 5-minute break. Okay, looks like everyone wants to continue. Let's do it. All right. So the hands-on session is split into 2 parts. The first part is going to be all of you, whoever has a laptop and want to do it. We are going to be writing 2 policies, one for governance and the other one for pod security. So we are going to be writing 2 policies and doing an end-to-end, all the way from writing the policies, testing them, automating and testing them manually, as well as automating them. And the next steps would be, I think I have this. Yeah. And the next steps would be the advanced use cases, where Sagar would be doing a demo of the generate, validate images, like basically policies like this. So because this is with the assumption that everyone is new to Kyverno, let's start with the basics. So does everyone have everything that's listed on the slide right now? Whoever wants to do the hands-on session. Do you have at least a single node cluster like Kind or something installed where you can test your policy, Helm to install Kyverno, an IDE or Vim if you are a fan of CLI to write your own policy? Okay. So whoever, like, I don't see many laptops being on, so who wants to do a hands-on session? Okay, perfect. So do you have stuff installed? Like, do you have your cluster ready and stuff?
I don't have Kyverno installed.
Yeah, so the next steps, yeah. So if you need help, Sagar and Dolis are here. Just raise your hand. One of them is going to be coming to you to help you with this. These are the next steps. Then other 2, Kyverno CLI and chainsaw test, are basically for test automation. You have a policy, but you want to test it end-to-end. Kyverno CLI is your unit test, and chainsaw is your end-to-end test. So again, these are optional. If you don't want to do it, that's fine. But again, if you want to start with getting started with the policies, please install Kyverno. We can get started with that. I'll wait for a couple of minutes for everyone to get started. Again, we'll go over the validation, failure action, audit versus enforce in real time during the hands-on demo. But this is the message. You are basically saying the fields, in this case, this is basically requiring run as a non-root user. So it's saying, okay, the running as root user is not allowed. And the message specifically says which one of these pods has violated the policy. So even for the end user, this will be extremely helpful in understanding what they need to fix, not just there is an issue. And for the purpose of the hands-on session, we are going to be doing 3 types of tests. The first one is a manual. So we'll create a policy, deploy a resource, make sure that the policy is violated. That's the hands-on. The second one is a unit test, an automation where it does a very brief check of the policy versus resources. And the third one is going to be an end-to-end automation test, where we are going to be doing an entire test all the way from deploying the policy to deploying the policy on a cluster, and which is what we required some kind of cluster to be. So we are going to be deploying the policy, testing it with good pod, bad pod examples, so that it lets the good pods go through and actually stops the bad pods. And so these are the 3 tests we are going to be doing: the Kyverno CLI and chainsaw test. And the main advantage of the chainsaw test, the end-to-end test, is again, this can be integrated into your CI/CD pipelines. so that any new resource coming in is validated before it actually hits your staging or production environments. I won't be going into in-depth into these, but what we are going to be doing a hands-on session is a validation rule. So there are multiple types of rules, and the simplest of all is a validation rule where we are going to test whether the resource or the manifest is passing/failing against a set criteria that we have. So it can be run as non-root, it can be as simple as, okay, I need limits on memory and CPU usage to be requested on every manifest, so it can be as simple as that to a complicated use case. So we are going to be doing the validation rule, and it can be run in two ways. It can be either in audit mode or enforce mode. Audit mode is typically set in like staging, dev environments, test environments and stuff, where you are okay with the developers creating these resources, but you want to gain access if something goes wrong. So if there is a policy violation, you would want to know that. But you would want them to create this resource no matter what. So that's fine. This is in audit mode. In enforce mode, say something like in production, like someone is running a root user, that's a huge no. So you don't want that to happen. So you set your policy in enforce mode, where if the policy criteria is met, it will actually stop the resource from getting created. And it would say, hey, like this exact policy is violated, but by this container or ephemeral resource or whatever it may be, this is being violated and it cannot be deployed till that is fixed. So just a quick thing, and for the purpose of the lab, we are, I think, almost done with the first few parts of it, where we created the kind cluster, installed Kyverno and stuff. So if everyone is ready, let's directly jump on to the hands-on session. Okay, perfect.
Okay.
So let's go here, maybe too small.
Is this fine?
Is this okay? Okay. So, again, if you clone the GitHub repo that was shown at the beginning, you are going to be doing the same as well. Let's go to labs. And I have two policies now. So I'm testing a governance policy and a pod security policy. Let's start with the governance policy. I'm requiring all the resources that are coming in to have a label. It can be anything. It can be a team, organization, an app name. It may be anything. So let's quickly take a look at the policy itself. So if you clone the repo, you already have this policy. So this is my policy. So my policy is, again, I give it a name, require labels, and I give some annotations to it so that I can track the policy much more easily. And I give a description of what the policy is, but here if you see, I'm setting the policy in audit mode. And once I have that, here I'm giving the label a message, and this is where the actual policy verification happens. So I'm saying, okay, again, for the purpose of the demo, let's move on to the end, where I've actually commented out. Again, you can have your own label here. You can have teams, you can have organizations, have any label that you want. But for this, I have put that the label required is a name. So it should have something called app.kubernetes.io/name, and the name can be anything. So as long as the manifest has a name, I'm good with that.
And the value, kind of
Yeah, it can be, yes.
repeat the question.
I'm sorry?
Repeat the question, please.
No, yeah, the question was, can the value be a wildcard? So yes, it can be a wildcard because, again, you can make it as broad or as granular as possible. I'm making it broad where I'm saying as long as it has a name, I'm good with that. So I'm just making sure that all my Kyverno policies are up, Kyverno pods are up. Oh.
Store. Okay.
One quick minute.
So,
There you go. So I have all my pods running, which is good. Let me give it a minute. A couple of pods are still coming up. So let me just give it a minute for them to come up.
Welcome, Switchless.
Sorry, 101 of any demo. It doesn't work the way when you want it to work. So. Local path storage. Let's see if this is okay. This should be fine mostly. Okay, now let's take a look at the policies. I don't have, okay, I delete. Okay, so all my policies are deleted. So let's apply my new policy. So K apply minus F, and I'm applying my policy. So the policy is created. I can validate whether the policy is applied or not by using kubectl get cpol. So it says my policy is applied and it's ready to be used. So let's take step one, which is the manual test. So I have a resource YAML which has the examples for both good pod, bad pod. So the first one is bad pod, where I don't have, because if you go back to the requirement, my requirement is it should have app.kubernetes.io/name. It can be anything. But this pod doesn't have it. If I look at the second example, I do have a label, but the label is not the label that I need. Now, the third example is the exact one that I need. And if you remember, we have created the policy in audit mode, right? So irrespective of what happens, all three pods should be created. Okay, so let's apply this. All right, so I try to apply this, and as expected, because this is in audit mode, all three pods are created. But how would I know that, though it is in audit mode, that there are pods that actually violated the policy that I just set? I have 1 minute, I'll just put this down, easy to type. So kubectl get polar, which is policy reports. And because this is in default, I don't need a -a. I hit this, and as you can see, I get my reports. I see that the good pod has passed, and bad pod 01 and bad pod 02 have failures. So if I want to take a look at it in detail, I can just do the same thing. Take one of the policy reports, do a -o YAML, and it actually gives me the policy report. So again, because I have not set the message properly, it says the message label name is required, which again, I have not done it properly, but it shows me the name of the pod, the message, and what is the path where it has actually not set. So again, a very quick overview that it does show me, again, this is in audit mode, again, something that we can try it in staging or dev environments. So because this is again a manual test, let's look at automation. As I said, we have two automations, a unit test, which is a Kyverno CLI test, and a chainsaw test, which is an end-to-end test. So I have created two folders for the same. So this is my Kyverno test. Let's quickly take a look at how the Kyverno test looks like. It's very simple. I am applying a policy, and I'm testing it against a specific resource.yaml. And I'm saying that the bad pod 01 should fail, bad pod 02 should fail, and good pod 01 should pass. So it's not applying the policy, or it's not applying the test it's not doing the test by applying the policy on a cluster. It's just doing it without Kyverno. It can be run without Kyverno installed on a cluster, Kyverno CL. Again, that's the reason this is a unit test. And for this, all I need to do is Kyverno test, show the path, hit enter, and the test is as I expected it to be. Now, let's go back to chainsaw test, which is an end-to-end test. So what this does is it does an exact step-by-step of how a user does it. So I need to be running it on a live cluster with Kyverno running on it, because again, this is as a user does, as how a user does it. So as step one, it will actually apply the file. It will apply the file like how I did kubectl apply. And then because we have it in audit mode, I'm doing a patch. I'm saying that the policy should not be in audit mode, it should be on enforce mode just for this. And I'm checking it against an assert file just to make sure that the patch is applied. And then I test it against a good resource and a bad resource, where the good resource should go through and the bad resource, in this case, should be stopped because it's in enforce mode. So let's take a look at it quickly on how this runs. So if I go back, it creates a namespace, a sample namespace during the test. It applies the policy, it checks the assert, it does the patch, it checks whether with the assert, and after that, it is trying to create the good pod, bad pod. But again, bad pod 01, again, this is exactly how the user would see it if the policy is put on enforce mode. Bad pod 01 was blocked due to the following policies, and again, if I would have put a proper this thing, it would show it there. Same is the case with bad pod 02, and good pod 01 was created without any issues. So at the end of it, it deletes the namespace that it just created, and it's good to go. So the test that I just did is a pass. So we have taken a look at all three. I'd like to take a quick pause here. Any questions, comments about what we have seen, because this is the first policy.
Stop. Regarding the scale, like if we see a large number of requests to the admission controller for Kyverno, how would it react? Like if it gets overkill, like will the request still pass through, or what will happen in that situation?
So the question was what happens if there are a large number of requests coming to the admission controller. So you can, it's not just a single pod that's actually running it. So you can actually scale it up and down depending on how you seem fit. The default behavior is we create 3 admission controller pods that take care of everything. You can scale it up higher if you think the number, like your number of requests will be much higher. So like any other Kubernetes resource or application, you can scale it based on, like this is not going to be, like the admission controller is not going to be your bottleneck. Okay, so we'll have the last 10 minutes again for any questions and answers. But anything that we have seen till now on how the policy works, the validation rules, the testing, any questions till then?
Can you show me, can you show me if it's going to be logged, for example, I put it as an audit instead of enforce. Can I look as a log on the admission controller?
Oh yeah. Yes. So you can see it as a log in like everything is logged, not just validation, the mutation. If you have a mutation policy, if it mutates a resource, it is going to be logged as well. So anything that happens is going to be logged in here. So you can set alerts based on that. So if there is a policy violation or a mutation that happens that you need to know about, you can set alerts based on that. And you can grab the data and say, for example, send it to your Grafana dashboard or use Prometheus or something just to get alerted if something happens in there.
Hello everyone. So now that you have gone through some of the fundamentals of Kyverno, you understand what Kyverno is. We'll cover some advanced use cases. One common thing or notion that everyone has is Kyverno is mostly used for validating resources, but that's not the case. There are other policy types of Kyverno, and we will go through them now and we'll see what other problems Kyverno can solve. So I'll go through each of these policy types followed by a quick demo. And some of these policies were already briefly covered by Dolis, but I'll dive deep into this. So think of mutation policies as your cluster's spell checker, but for YAML, automatic spell checker, but for YAML. So mutation policies let you automatically modify your Kubernetes resources as they are created or updated, right? And so if you think about it, why do you need mutation policies in the first place? So Kubernetes, I think, is the only platform that is touched by all the teams. So we have security teams, platform teams, and development teams, right? Each team cares about only specific things. For example, to be honest, development teams really don't care about setting the resource limits. All they want is they want their application to be up and running, right? So it becomes a responsibility of a platform team to make sure they are configuring the resource limits, right? Because if they don't do that, that development application is going to take up the entire CPU or memory, right? And if you think about security teams, they mostly care about things like security context. They want all the containers to run as non-root, right? So it is important that any workload that's coming in, either they have to be compliant with the security rules, or that resource has to be mutated to make sure they're compliant. So this is the main use case of mutation policies. And we have seen in the community and working with other customers that very common use cases of mutation policies is adding image pull secret. Let's say you are trying to deploy something, and if there's no image pull secret, you want to automatically add a image pull secret. And the very popular use case is automatically mutating the image registry, because when application teams are deploying different deployments, every organization has its own requirement. They should not pull images from docker.io and so on, right? So you can use mutation policies to automatically change the registry and use your organizational image registry. So that's a very popular use case. And with mutation policies, there are different schemes. We have JSON patch and strategic merge patch. So these are the two mutation mechanisms that we have. Both have different sets of use cases, right? JSON strategic merge patch is basically allows you to use anchors. Anchors are like if conditions in your policies, whereas JSON patch doesn't allow you to do that. And mutation policies not only allow you to mutate new resources, you can also mutate existing resources. And if you are using GitOps approach to deploy your resources, there are a few things that you have to keep in mind, especially you have to enable server-side apply when you're deploying these mutation policies for all of these to work seamlessly. Now, let's quickly look into the examples of merge strategic patch. As you can see from my screen here, I have two policies. On the left side, we have a simple policy which uses patch strategic merge, and it is adding a label department equal to engineering. And on the right side, you have a little more complex policy, where based on the image that you are using, based on these images, you are adding a image pull secret to your deployment. So yeah, in the next slide, we can see some example of JSON patch. So with JSON patch, you can actually remove certain fields. For example, in the left side, you can see that you are removing a label called as purpose, right? And it is using JSON patch. Likewise, on the right side, you are adding certain fields to a pod label, right? So this is a priority class. So basically, you are adding a value to the priority class. So let's quickly check one example in action so that you can understand this. So in the interest of time, I have already deployed the policies, right? So let's take a look at the add labels policy. So this is again a simple policy that adds a label foo equal to bar. So let's deploy a sample pod and see how that looks. Okay. So the pod has been applied. Let's take a look at that. Yeah, sure enough, the label has been added, as you can see, and the policy that we had was this one. So this is a simple policy to add a label, right? And it is using patch strategic merge. All right. Moving on from here, let's go to the generation policies. So generation policies basically allow you to generate net new resources, right? And why would you use generation policies? So generation policies allow you to automate stuff in your cluster. For example, bootstrapping namespaces. Let's say you are trying to create namespaces for different application teams or dev teams, right? And you want some defaults in that namespace. For example, creating network policies, right? It's a very common thing. You don't want resources in one namespace to talk to another namespaces. So network policies is a must from a security standpoint. So you can create that. And you can also create some baseline RBAC, right? For example, when a namespace is created, you want to make sure development teams have access to that namespace. So a default RBAC has to be created, like role binding and so on. And then another typical example why you would use these policies is syncing namespaces, syncing secrets. Let's say you have a secret in one namespace and you want to distribute that secret across all the namespaces. In that case as well, you can create generation policies. So here is a simple policy that you can see that I just mentioned. On the left side, we have a generation policy that is creating a default deny network policy in the new namespace that it creates. And on the right side, you can see that we are basically syncing a secret from one namespace to another. So it's basically cloning. As you can see that there's a clone keyword in the policy on the right side. So it's basically cloning a secret from default namespace, and the name of that secret is regcred. So just want to talk about the general behavior of generation policies, right? So basically with generation policies, you have a trigger resource, right? And you have a target resource. So whenever you create a trigger resource, for example, a namespace, a target resource is created. And when you delete the policy, the target resource is deleted as well, right? And this is actually controlled by a field called as synchronize. So if you set synchronize option to false, then your target resource is not deleted. And generation policies also support different kinds of operators. For example, there is a special variable called at that is used to reference a field's current value. So you can use that in your policy as well. So let's go through a quick demo of how a generation policy looks. So let's switch to the terminal. So I have already deployed the generate policy here in the interest of time. So let's get cpol. So this is the generation policy that we have, and it actually creates a network policy when a new namespace is created. So let's see how that looks. Okay, as you can see that I just created a new namespace and a network policy was created by default in that namespace. So this is how you can bootstrap namespaces, and this definitely saves a lot of time if you are a platform engineer trying to automate things. Let's move on from the generate policies. Now that we have seen mutation and generation policies, we'll quickly cover image verification rules. Image verification rules basically allow you to sign the image signatures, and you can actually validate the images based on the policies, Kyverno policies. And you can not only sign image signatures, you can also sign attestations. So attestations are basically metadata of images, and you can validate the attestations based on the policy as well. Yeah, so this is a typical policy that is used to verify the signature of an image. So basically you are passing a public key, and basically we are checking whether the image signature is present in the OCI registry or not, and it is being applied to all these image types. All right, so we may not have time to show the demo of image verify policy, so I'll quickly summarize. To sum up, we have gone through the mutation policies and generation policies, and if you use all of these in combination along with image verify rules, Kyverno can be a game changer, and policy as code is really helpful, and it automates security from end to end. Happy to hear any feedback or thoughts that you have.